All right, hey guys. I'm out of practice on these videos. Hang on, let me let that bell finish up. Okay. We're gonna talk about two-step equations today. Your first assignment of the day, though, you're gonna do a mix of single-step problems. So before you do that, hang on. I just kind of want to do a little summary for you guys. So far, let me get my computer into a good position. I don't have my little board to do this with, so it's going to be a little bit messy. So far, we've used mass. Sorry. We've used volume. We've used representative particles. I'm going to put RP. And we have mole. Okay, mass, of course, is measured in grams. To find mass, or to use mass, the number you use, is your molar mass from the periodic table. So you have to calculate that. Okay, volume is measured in liters. We know that we have 22.4 liters per mole. Okay, so molar mass is in grams per 1 mole. We know liters is in liters per 1 mole. Representative particles. Now remember, representative particles can be a lot of different things. It can be atoms. It can be molecules. It could be particles. It can be formula units or just units. So FU, not cussing at you. It's just the abbreviation. Those are the main ones. Sometimes you see ions, all that kind of stuff. Those are representative particles. And remember, for representative particles, we use 6.02 times 10 to the 23rd, whatevers per mole. And then, of course, with mole, we just use the number 1 because everything is per 1 mole. Okay, so that's just a little summary for you guys. So if you see grams, you're going to use to figure out your molar mass. If you see volume in liters, you're going to use 22.4. Any of the representative particles, you're going to put down 6.02 times 10 to the 23rd. And then if you see mole, you're going to put down 1. Okay, so your first assignment is the mixed practice. I can't remember which one it is. I think it's like, I don't know. It'll be on Canvas anyway. I think it's like mixed mole conversions or something. After you guys do that, then we're going to go into multiple step mole conversions. So I'm going to go ahead and teach that to you. You can pause this while you work on the other stuff or whatever and come back to it later, or you can just watch it through now. So let's talk about two-step equations. Here's a way to know that you have a multiple step mole problem. You're not going to see the word mole in the word problem. Okay, this is just kind of a little like a flow chart for you. That may or may not be helpful. If that's messy for you, don't worry about it. If it's something you think can help you, go ahead and take a look at it. There's a copy of one very similar to this in your packet. It's one of the first pages. So if we have volume, if we're going from liters to moles, we're going to divide by 22.4 liters. Moles to liters, multiply by 22.4. Of course, mass, grams to the mole. We're going to use our molar mass over here with representative particles, usually atoms, molecules, formula units, particles. We're going to use 6.02 times 10 to the 23rd. Now, we can also go, looking at this flow chart, we can go from volume to representative particles. We just have to go through the mole. We can go from mass to representative particles by going through the mole. So basically what that's telling you is you're going to have to convert to moles first, and then from moles to the other thing. Okay, so again, you won't see the word mole in the word problem. So let's take a look at an example. All right, a sample of H2O contains 2.76 times 10 to the 5th molecules. We want to know the mass in grams of the sample. So as you can see, the word mole is not in there. Okay, and we're going to start this like we do all of our problems. We're going to just start with a given. So we have 2. Try writing this better. times 10 to the 5th molecules of H2O. All right, I'm going to do my train tracks just like usual. So I know that down here we have to have molecules of H2O because we're going to have to cancel that out. Now, what number goes with molecules? Avogadro's number, 6.02 times 10 to the 23rd. And we know there's 6.02 times 10 to the 23rd molecules in 1 mole. So we always put 1 with the mole until we get to the next unit. All right, now we've canceled out molecules of water. Now we're in moles of water, but we need to get to the mass of water. So again, in following the canceling out with them being diagonal, we know we have to put moles of H2O down here. And again, 1 goes with mole. If we want to switch moles to mass, grams of H2O, we're going to have to find the molar mass of H2O. Oxygen is 16. Each hydrogen is 1.01. So that gives us 18.02 grams is the molar mass of H2O. So we know that in 1 mole of water has a mass of 18.02 grams. So we've canceled out moles of water. So now we're in grams, which is what we want to be in. So now it's time just to do our math. So I'm going to do my 2.76, 10 to the 5th, times 18.02. Then I'm going to divide by 6.02 to the 23rd. And I get 8.26 times 10 to the negative 18th. And of course, the only unit left is the grams here. Grams of water. Okay, so things really didn't change. We're doing a mole conversion, but then we're converting back from moles to something else to follow along because we wanted to go from molecules to mass. So that's a representative particle. So what we did is we divided by our 6.02 times 10 to the 23rd, and we multiplied by our molar mass to get back to mass. All right, let's try another one. This one, we have a 28.7 gram sample of magnesium phosphate, and we want to know how many formula units it contains. Okay, just to be clear, formula unit is 1 unit of an ionic compound. Okay, so that just means we have 1 Mg3PO42. You know how we did reactions. If we had 2 Mg3PO42s, that just means we would have 2 of these. Okay, so that's all that is, formula units. It's just a way to describe that. Erase that. Okay, so we're going to start with our given, 28.7 grams of Mg3PO42. So of course, we know that on the bottom we have to have grams of Mg3PO42. This is so hard to write with a stylus. All right, so we need to find our molar mass of that. Shoot, let me see if I've got it. I think I've got it somewhere, so I don't have to figure it out right now. I don't mix moles. My bad, I don't have it. So let me figure it out super quick here. All right, so we got Mg is 24.31, and we've got 3 of those. Plus, we've got phosphorus, 30.97, and we have 2 of those. Plus, oxygen is 16, and it looks like we have 8 of those. So 262.87 is the molar mass. Okay, so we know we have 262.87 grams of magnesium phosphate in 1 mole of magnesium phosphate. Okay. Now, of course, I got rid of grams. but I'm trying to get to formula units. I'm not there yet. I'm in moles. So we know we're going to have to cancel out moles. And we know 1 goes with mole. Sorry. Okay. In 1 mole of magnesium phosphate, we're dealing with how many formula units of magnesium phosphate? Of course, formula units is a representative particle. So we've got 6.02 times 10 to the 23rd. So we've gotten rid of moles. We're in formula units, so it's time to do our math. So we're going to do our 28.7 times 6.02, second E, 23, divided by 262.87. And I get 6.57 times 10 to the 22nd formula units of Mg3 PO42. Okay. I'll leave this example here for you guys. I'm not going to write it down again right now, but what is the mass? It's just another example of 44.8 liters of oxygen. Of course, we're starting with 44.8 liters. I've already crossed that out. That's why it looks like that. It's not a 0. So we're going to cancel out down here liters of oxygen, and we know the number that goes with liters is 22.4 per 1 mole. Then we've got to cancel out the mole and get to grams. Oxygen is, of course, a diatomic, so we have to consider that there are 2 of them. So that makes it 32 grams of oxygen, and what you get there is 44.8 times 32 by 22.4, so it's 64. Grams of oxygen. Okay, I hope that makes sense. Just follow along with Canvas as far as your assignments go. I will add a place to upload your assignments. You need to take a picture. You got to show all your work, guys. So do everything on a separate piece of paper. Show all of your work, including your answer rounded to decimal places with your unit and of what. So grams of O2, so on and so forth. Make sure you show me all that. And then the day after the day that it's due, that afternoon, I'll post the answer key. Okay. And again, make sure you email me if you have any problems, and we'll do a Teams meeting. So, all right. I hope you guys have a great first virtual day.